Good afternoon, everyone. I welcome you all again to today's session on regression and correlation using SPSS. For this session, we have with us Dr. Jonali Gogoi from Assam University. Ma'am has already shared her knowledge with us on SPSS system. I am very glad that today also she will deliver her speech on regression and correlation with her participants. Now, I like to invite Dr. Jonali Gogoi to deliver her talk. Ma'am, please proceed.
Hello everyone. Again I welcome all of you to my second lecture of this 1 week faculty development program on scientific software. Today's my presentation topic is correlation and regression in SPSS. But before going to start in SPSS, I just want to give some theoretical knowledge, theoretical idea about both correlation and regression. So let's start. Correlation. Simply it means, you see here I am writing co, that means together, and relation means connection. So we can say co, together, relation, connection. This is correlation. These are the contents what I am going to discuss here. So what is correlation? That means what is the definition of correlation? Then next I am going to explain what are the types of correlation. Then I am going to explain about the methods how to study correlation. And what are the properties of correlation coefficient and how we can interpret of correlation coefficient. So these all things I am going to discuss here. First you see, the correlation is a statistical tool which studies the relationship between two variables. Suppose we are considering x and y. These are the two variables and we are going to find out the relationship between these two variables. Then this is called the correlation between them. And next point, two variables are said to be correlated if the change in one variable results in a corresponding change in the other variable. If x is change, then again it results in the corresponding change in the y variable. And the degree of association between two or more variables is termed as correlation. And this correlation analysis helps us to decide the strength of the linear relationship between two variables. Next, types of correlation. There are lots of types for correlation. So first one is positive correlation, second one negative correlation, zero correlation, perfect positive correlation, perfect negative correlation, linear and non-linear correlation, spurious or nonsense correlation. So how we can explain all these correlations? Let's see. Positive correlation. Two variables we are considering here, x and y, are said to have the positive correlation if for a change in the value of any one of them, the value of the other variable also changes in the same direction. How we can say this is in same direction? For example, we can say height and weight, income and expenditure of a family. So these are the examples of positive correlation. If height increases, then weight also increases. So next point, negative correlation. Two variables x and y are said to be correlated if for a change in the value of any one of them, the value of the other variable also changes in the opposite direction. Now you see, in case of positive correlation, this is in the same direction, and in case of negative correlation, you see this is in the opposite direction. For example, price of a commodity and demand for it. So this is the example of your negative correlation. Zero correlation. If two variables are independent, then they are uncorrelated. For example, results of PG students and rainfall. That means results of PG students and the rainfall, there is no relationship between these two variables. So if two variables are independent, because here results of PG students and rainfall both are independent. What is independent and dependent variables? Suppose we are considering a straight line equation y equal to a plus bx, then here we can say y is independent variable and x is y is dependent variable and x is independent variable. So but here both the variables are independent. In that case we are getting zero correlation. Perfect positive correlation. What is this? Two variables x and y are said to have the perfect positive correlation if for a change in the value of any one of them, the value of the other variable also changes in the same direction and in the same ratio. For example, temperature and volume. What is perfect positive? In case of perfect positive, only same direction, but perfect positive correlation, same direction and in the same ratio. This is called perfect positive correlation. Perfect negative correlation. Two variables x and y are said to be correlated if for a change in the value of any one of them, the value of the other variable also changes in the opposite direction but in the same ratio. For perfect negative correlation, this is in the opposite direction but in the same ratio. For example, we can say pressure and volume. This is the example of perfect negative correlation. The next, what is linear and non-linear correlation? If the amount of change in one variable tends to bear a constant ratio to the amount of change in the other variable, then this correlation is said to be linear. For example, amount of deposits in a savings bank account and the interest income of the depositor. And if the amount of change in one variable does not bear a constant ratio to the amount of change in the other variable, then the correlation is said to be nonlinear, or we can say another name for nonlinear, curvilinear. So for example, amount of rainfall and yield of crop. This is the example of nonlinear correlation. And last one, what is spurious or nonsense correlation? For two variables, it is not possible to explain the causal relationship between them, but the correlation is calculated merely on numerical basis, is called nonsense correlation. So you see, for example, number of deaths in India due to snake bite and number of fresh graduates. This is the example of nonsense correlation. So this is all about the types of correlation. Next, methods how to study correlation. So now you see, from correlation we are getting graphical method and algebraic method. That means there are two methods to study correlation. One is graphical method and another one is called algebraic method. In graphical method, what we are using here, scatter diagram method, and in case of algebraic method we are using Karl-Pearson's coefficient of correlation. So these two are the methods to study our correlation. So what is scatter diagram method? Scatter diagram is a graphic method of finding out relationship between the variables, and the given data are plotted on a graph paper in the form of dots. That means we denote to draw scatter diagram as dots. That is, for each pair of x and y values, we put a dot and thus obtain as many points as the number of observations. And with the help of scatter diagram method, we can study the nature of relationship between the two variables. Here you see types of correlation. This is with the help of scatter diagram method. Here first diagram is positive and second one is negative correlation. This is null. This is linear correlation. This is look like as exponential, and this is as U-shaped. And here you see the dots or points are from bottom to top. That means left bottom to right top. This is called your positive correlation. And here you see, in case of negative correlation, left top to right bottom. This is called your negative correlation. So this is look like as linear. So that's why this is linear correlation. This is look like as exponential curve. That's why this is called exponential correlation. And this is look like as U-shaped. That's why this is called U-shaped correlation. And now you see from these three diagrams, this is the strength of correlation. So how we can explain? Here you see this is look like as linear. That's why this is called your strong correlation. And here you see this is called weak correlation. And here nothing, none. That means no correlation. So these all are the diagrams with the help of scatter diagram method. Next I am going to explain about Karl-Pearson's coefficient of correlation. So the degree of linear relationship between two variables, Karl-Pearson, who was a British biometrician, developed a formula which is called correlation coefficient. So correlation coefficient is denoted by small r, which is equal to, we can write rxy. This is for two variables, that's why I am writing here xy. Or we can write this is equal to r within the first bracket x comma y. This is equal to covariance of x comma y divided by sigma x and sigma y. These are what? Sigma x and sigma y. These are the standard deviation. And now you see the range of r, that means the range of correlation coefficient is from -1 to +1. Here you see this is -1, then 0 and 1. If -1, then there is strong negative correlation. If the values are 0, then there is no linear relation. And if 1, then we'll get their strong positive correlation. Next, properties of correlation coefficient. So first property, the correlation coefficient is a pure number, that is, it is free from unit. And it is independent of change of origin and scale. Correlation coefficient lies between -1 to +1, that is, we can write -1 less than equal to r less than equal to 1. The sign of correlation coefficient depends on the sign of covariance. The coefficient of correlation is the geometric mean of the two regression coefficients. That is, we can write correlation coefficient r equal to root over bxy into byx. Bxy and byx, these two are the regression coefficients. So these are the properties of correlation coefficient. Now interpretation of correlation coefficient. How we can interpret? Number 1, r equal to +1. What does it mean? This indicates perfect positive correlation. That is what? There is an equal proportional change in both the variables and in the same direction. For example, here I have considered first variable x 2, 4, 6, 8 and y 10, 20, 30, 40. Now you see what is the difference between these variables? 2 to 4, 2, then 4 to 6, 2 again, 6 to 8, 2 again. And here you see 10 to 20, 20 to 30, 30 to 40. All are in 10 differences. Therefore, what is the rate of change? 2 by 10. So, in case of perfect positive correlation, we always get a linear correlation. And mathematically, how we can write? This is y equal to a plus bx type. Number 2, r equal to -1. What is this? If r equal to -1, then this is the perfect negative correlation. That means there is an equal proportional change in both the variables and in the opposite direction. For example, you see x 10, 20, 30, 40. Here difference is 10. And y 25, 20, 15, 10. Here is 5. But here is in increasing order and here is in decreasing order. In case of x, here you see this is in increasing order 10, 20, 30, 40, and in case of y, here you see this is in decreasing order 25, 20, 15, 10. So what is the rate of change here? 10 by 5. So we can express perfect negative correlation as linear correlation. How we can write mathematically? Y equal to a plus minus bx type. So this is the perfect negative correlation. What is r equal to 0? How we can interpret if r equal to 0? This means that the variables are uncorrelated. That means there is no linear relationship between the variables. For example, here you see x equal to -2, -1, 0, 1, 2 and y 4, 1, 0, 1, 4. In this case, if we are going to find out the covariance between these two variables, then we will get 0. Therefore, if covariance equal to 0, then what is the formula for correlation coefficient? Here you see r equal to covariance of xy by sigma x into sigma y. If this covariance equal to 0, then we will get r equal to 0. Number 4, the value of r very close to 0. What does it mean? If this is very close to 0, r is very close to 0, this means very little correlation between the variables. The value of r near to +1 or -1, this means y is highly dependent on x, or we can say x is highly dependent on y. When r equal to 0.7 to 0.999, what does it mean? There is high degree of correlation. When r equal to 0.5 to 0.699, then we can say there is a moderate degree of correlation in between 0.5 to 0.699. And when r is less than 0.5, then there is a low degree of correlation. So this all are the interpretation on correlation coefficient. Next, we are going to use all this correlation in SPSS. So I have already told what is the full form of SPSS, statistical package for the social sciences. Now here I have considered one example for correlation. So here the data for the age of 9 mango trees in years and the average length of their leaves in inches are given. So here age and here length. Now you see, the question is, we have to calculate the correlation coefficient. That means we have to find the value of r and just you comment on your result. So this is your question. Okay, these are the data and this is your question. Now you see how we can perform. I have given here the SPSS code. Now you see correlation coefficient on SPSS, how we can perform. First you click on analyze. When you open your SPSS window, then you first analyze, click on analyze, then correlate, then bivariate, then variables, then select the variables age and length, then you click on correlation coefficient and here you select Pearson's correlation coefficient. That means we are going to find out Carl Pearson's correlation coefficients. That's why you just select Pearson and then last you click on OK. Then you will get the result. But before going to do this, first you have to enter the values data in your data SPSS window. That means first you have to open your variable view window, and then first you name type all variable in variable view window, all you put the variable names and all, and after that you enter the data. After that you analyze your data. Okay, and after doing this we will get this type of window. Here you see, first these are data I have already plotted, means I have already entered the data in SPSS window. So here you see analyze. I'll show you in SPSS window again. Just I have taken here the screenshots for you. This is this will be easier for you if you see your this PowerPoint presentation, then you will find out how you have to perform. Okay, so just you click on this analyze. Here you see these all are in yellow color. Analyze, then you go for correlate, then you go for bivariate. After that it will come age in years and length of leaves. Just you click on this age in years. Here you see age and length. Select the variable, that means age and length. So here you see age in years and length of leaves. You just click on age in years, then you click on here this arrow button. These are the variables, it will come here, and then again if you click on length of leaves, again you click here arrow button, then it will come here in this box, and then here you see Pearson, Kendall, Spearman. So we are going to find out only here Pearson's correlation coefficient. That's why you just tick on Pearson, and then after that OK. Here you see age in years, length of leaves, it will come here, then you just click on OK. So after clicking on OK, then what will come? This is your result. This is your result. Okay. Now you see, so Pearson's correlation, here you see this is minus 0.99. How we can conclude on the basis of this table, this results, how we can give how we can draw our conclusion. See, correlation coefficient, I told you this is minus 0.99. How we can comment? I have already given to you all in detail about the interpretation of correlation coefficient. So here the value and we know the range for correlation coefficient is -1 to +1. So that's why you see here the value is minus 0.599. So how we can interpret, how we can conclude on the basis of this result. So now you see, from the I have given here the conclusion part. From the value we can conclude that there is moderate relationship between the variables, and thus negative sign indicates that the variables are negatively correlated. Here minus sign is there, so that's why we can say that variables are negatively correlated. That is what we can conclude. Increase in the ages of trees, mango trees, will decrease the length of the leaves. So this is the conclusion. I think all of you have clear. Next, I am going to explain about what is regression. So the term regression means stepping back towards the average. Regression is concerned with the prediction of the most likely value of one variable when the value of the other variable is known. And regression was first used by British biometrician Sir Francis Galton. And what is the definition for regression? Regression analysis is a mathematical measure of the average relationship between two or more variables in terms of original units of the data. That means in case of correlation, there are linear relationship between two variables, and here average relationship between two or more variables. This is called the regression. In regression analysis, there are two types of variables here. We will get independent and dependent variable. So what is dependent variable? What is independent variable? The dependent variable, we can say the variable whose value is influenced or is to be predicted is called dependent variable. For independent variable, the variable whose influences the values or it is used for prediction is called independent variable. And in regression analysis, independent variable is known as regressor, or we can say predictor, or we can say explanatory variable. And in dependent variable, in regression analysis, dependent variable is called as regressed or explained variable. Now, the lines of regression. A line fitted to a set of data points to estimate the relationship between two variables is called regression line. So, we have here two lines of regression. One is called y on x and another one is called x on y. So, the regression equation of y on x, which describes the changes in the value of y for given changes in the value of x. The regression equation of x on y, which describes the changes in the value of x for given changes in the value of y. An equation for estimating a dependent variable y for x from the independent variable y, x or y is called regression equation of y on x or x on y respectively. Now the types of regression. Here I am going to describe about simple regression and multiple regression. There are two types of regression. One is called simple regression and multiple regression. What is the definition for simple regression? If regression analysis is confined to study of two variables only, then it is called simple regression. And the regression analysis that studies more than two variables at the same time, which is called multiple regression. So what is multiple regression? Predicting an outcome based upon several independent variables simultaneously. Or we can say multiple linear regression is a statistical technique that uses several explanatory variables to predict the outcome of a response variable. Why multiple regression is important? Behavior is rarely a function of just one variable, but is instead influenced by many variables. So the idea is that we should be able to obtain a more accurate predicted score if using multiple variables to predict our outcome. That's why it is important. Now here I have considered one example for regression. So here the data are given. These are the data for heights, weights and gender of a group of children. So these are for heights and these data are for weight, and these are mentioning here the gender of this data set. Now our question is, from this data set we have to draw a scatter diagram with height along x-axis with the fitted line diagram, and again you have to find the regression line of weight with respect to height, and again find a simple linear regression of weight with respect to height in SPSS, and also find multiple linear regression of weight with respect to height and gender in SPSS. Now first we move to our scatter diagram. So after entering all the data in SPSS window, first you click on graphs, then legacy dialogs, then scatter dot, select simple scatter, define, select height of the children to x-axis, select weight of the children to y-axis, and then last you click on OK. Then we will get what? You see, this is the screenshot of this SPSS window. Just you click on graphs, then legacy dialogs, then scatter dot. Then again what we will get? This type of window is coming. Then simple scatter, you just click on it, then define. Then here you see height of the children to your x-axis and weight of the children to your y-axis. So here you see, and then click OK. Then we'll get this diagram. This is called a scatter diagram. This is in x-axis height of the children, and in y-axis weight of the children. This is the scatter diagram. Next, regression line. So double click on the graph, then click elements, select fit line at total, and then lastly just you click on close. What is double click on the graph? We are getting this type of a graph. So just double click on this graph, then what we'll get, this type of window is coming. Then you click on elements, then fit line total. Then we'll get this diagram. So here y equal to minus 49.77 plus 0.592x, and r square is what? R square equal to 0.473. You see, this is the diagram. So how we can explain this? R square, what is R square? This is called the coefficient of determination, and it gives the proportion of the variance of our dependent variable that can be explained by variation in our independent variable. Thus 47.3%, that means here r square is here of 0.473. So 47.3% of variation in weight that can be explained by differences in height. Next, simple linear regression. Again you click on analyze, then regression, then linear, then put the variable weight of the children to dependent box, and again you put the variable height of the children to independent box. Then click on OK. You see, just go to analyze, then regression, all are in yellow color. Analyze, regression, linear, then you see height of the children in your independent box and weight of the children in your dependent box. Then click on OK. So we'll get this type of results. Here first table, variables entered removed, then model summary, then ANOVA table, and after that this one is coefficient. Okay, here the r square value is 0.473, and here constant height of the children you see minus 49.771 and 0.594. This is the these are the coefficients, value of a and b. This is level for value of a is labeled as constant, and for value of b it is labeled as height of the children. Now you see, it will be more clear. It occurs after the variable entered remove section. This is the model summary table, and this r square is called coefficient of determination, and we know it gives the proportion of the variation of our dependent variable that can be explained by variation in our independent variables, and thus 47.3% of variation in weight can be explained by differences in height. The standard error of estimate gives a measure of dispersion for our prediction equation. So now you see, the second part of the output is our ANOVA table. Now you see, this is the ANOVA table, and here the p value is 0.005. You see, 0.005. This is our p value. This is 0.005, which is less than 0.05. Okay, so here we have a significant linear regression. And what is our final section of the output? Now you see, our final section of the output is our coefficient table. So the final section of the output is the table of coefficients, and we know that the regression equation is y equal to a plus bx, and here y is called your dependent variable and x is called your independent variable. And from the table of the output, the values of both a and b are found in column B. That means you see, from this table, coefficient table, you see b is there for minus 49.771 and 0.594. So the first value is minus 49.771 is the value of a, which is labeled as constant, and the second value is your 0.594, which is the value of B. This is labeled as height of the children. So our prediction equation will be what? Weight equal to minus 49.771 plus 0.594. So this is our prediction equation. Next we move to our multiple linear regression. So again you click on analyze, then regression, then linear, then put the variable weight of the children to dependent box and put the variable height of the children and gender of the children to independent box, and then you click on OK. These are the SPSS codes, codes for multiple linear regression. Then you see again analyze, regression, linear. Then height of the children and gender of the children in independent box and weight of the children in your dependent box. And then click on OK, then we'll get this result. So here you see in model summary what is R square value 0.477, and here in ANOVA table here you see 0.021 is your p-value, and coefficients you see minus 44.533, this B column, this is in B column, 0.568 and minus 0.945. This is for the value constant, height of the children and gender of the children. Now our result and interpretation, you see for multiple linear regression we are interested in 3 components. Okay, so what is the model summary here? This is also same, it occurs after the variable entered removed section, and R square, this is called the coefficient of determination, which gives the proportion of the variation of our dependent variable that can be explained by variation in our independent variables, and thus 47.7% of variation, 47.7, just you see 0.477, R square value is this, so 47.7% of variation in weight can be explained by differences in height and gender. The standard error of estimate gives a measure of dispersion for our prediction equation. And the second part of the output is our ANOVA table. So you see from ANOVA table what we'll get. Our p-value is 0.021. Okay, so our p-value is 0.021, and which is also less than our 0.05. So here also we have a significant linear regression. So the final section of the output is the table of our coefficients, and for multiple regression the equation is what? Y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus plus beta z xz. Here this z is called the number of independent variable and y is the dependent variable, and x's, this x1 x2 up to xz, these x's are independent variables. So here our prediction equation for this example is, that means what we have considered this example of height, weight and gender. Weight equal to minus 44.533 plus 0.568 plus 0.945. That means here you see these are the values. Okay, so our prediction equation for this example will be this. Weight equal to minus 44.533 plus 0.568 height plus 0.945 gender. So this is all about our multiple linear regression. And now multiple linear regression equation, you see y equal to a plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus error term. This is, I have given equation number. What does it mean? Y is your number of children born per family. Here we have considered y equal to number of children born per family, equal to a, this is constant, plus this one age of marriage, and for this beta to x2, this is number of children that, plus income of the family for this and the error term. And in equation 1, here all factors y, x1, x2, x3 are having numerical quantity. All are numerical quantity. Therefore, it is called regression model. So, I have given all the details of simple multiple regression. So, I hope all of you understood about this. Again, I will perform all these things in our, that means I am going to show you in the SPSS window how we can perform. I have already given all the details here. This will help you in future, because when you see my presentation, then from this presentation you can perform your analysis on simple multiple regression, correlation, all those things, because I have already given all the codes here. And again, I will show you in SPSS window. Now I am going to show correlation and regression in SPSS window. So I have already considered the example for correlation. These are the data for the age of 9 mango trees in years, and the average length of their leaves in inches are given. So I am going to show, this is in SPSS window. Now you see, I have already opened my SPSS window, and here this is the example for correlation. This is data view window, and this is variable view window. First you have to give the variable view name in this window. First name, age and length I have given, then type numeric, both are numeric, then white, by default it is 8, then decimals I have selected, then label as in years, and length of leaves, and then values missing, columns align, this is right, and then measure roll. After entering this in variable view window, then you go for your data view window, click on data view window, then you just enter the data. These are the data I have already entered for you. Now you see how we can perform, to calculate our correlation coefficient. So first you go for analyze, this is analyze, then what is the next step? Correlate, then you go for bivariate. You see, analyze, then correlate, then bivariate. Just click on it, okay, then this will come. Then in this variables box, first you select the variable age in years, that means this one, and length, okay. Okay, just click on it, then this two will be appear here, and after that you select Pearson. I have already selected this one, Pearson, okay, because we are going to show here, calculate here Pearson's correlation coefficient. Just click on it, Pearson, then click OK. So what is coming? This is the correlation table. Age in years, then length of leaves, Pearson's correlation coefficient, and here you see length of leaves, age in years it is given. So correlation coefficient is here minus 0.599. Okay, so minus 0.599. So after that, what is the interpretation on this? I have already given here the interpretation. Just you see, from the value we can conclude that there is moderate relationship between the variables, and thus this negative sign indicates the variables are negatively correlated. Okay, that means increase in the ages of trees will decrease the length of the leaves. So this is all about correlation coefficient. Because I have already I have given all the interpretations on R. That means the correlation coefficient. So that's why from those interpretation we can conclude like this. And then after that you go for your regression, the example of regression, this one. So again you open your multiple regression. I have already entered the data. Now you see here example regression, height, weight, gender. It is given for data for the heights, weights and gender of a group of children. Then what we have to perform here, scatter diagram, regression line, simple linear regression, multiple linear regression. So from this you see I have already entered this variable view, height, weight, gender, then all the characteristics I have already fill up, and after that you go for your data view window. Then here you enter all the data, then you go to perform your scatter diagram from here. So how we can perform, just you click on graphs, then you go for legacy dialogues, and then you go for scatter oblique dot, just click on it, and then here you see simple scatter, matrix scatter, simple dot, overlay scatter, 3D scatter, like that. So you just click on this simple scatter, then you go for define. Okay, after go for define, you select height of the children to x-axis, height of the children, just click on it, this is in x-axis. Okay, and after that select weight of the children to y-axis, weight of the children to y-axis. I have already given the question. From that question we have to perform like this, and then you click on OK. So it will come. What happened? This graphs, then legacy dialogues, then scatter the dot, then select scatter, simple scatter, then define, height of the children to x-axis, weight of the children to this, and then OK. Okay, it is coming. Okay, now you see this is coming. This is the scatter diagram I have already performed. Then you go for a regression line. Next one is your regression line. So how we can perform? Okay, so this is regression line. So double click on the graph. Double click on the graph, then what will come? Just elements. Okay, just you click on here, elements, then fit line total, fit line at total. Okay, click on it, then close. So it is coming. In x-axis height of the children, and in y-axis weight of the children. Okay, we are getting here r square equal to 0.473, y equal to minus 49.77 plus 0.59 into x. So this is all about your regression line. Okay, then next what we'll do, again we'll do our simple linear regression. So for simple linear regression, you go to analyze, then go to regression, then linear, regression, then linear. Then put the variable weight of the children to dependent box and height of the children to independent box. Okay, then you just click on OK. Okay, so it is coming. It is coming. Here you see significant p value is 0.005, and here the constant for this B column I told you constant, that means the value of A for minus 49.771, and height of the children that means the value of B 0.594. So our regression simple linear regression equation, just you see, this weight equal to minus 49.771 plus 0.594 to height. Okay, this is our simple linear regression. Then again we move to our multiple linear regression. Can you go for here, sorry, not correlation, multiple regression. So here analyze, again you go to analyze, then regression, then linear, then put the variable weight of the children to dependent box, and I have already done, that's why it is coming like this, and then height of the children and gender of the children in your independent box. Okay, so then click OK. Then what is coming? This is the result. This is the result. So here you see the constant is minus 44.533, then 0.568, gender of the children is here minus 0.945, and here significant, that means the p value is here 0.021. This is also less than 0.05. Okay, so for this multiple linear regression we have already performed, and then now you see the conclusion part. Here again the same thing, what will get our prediction equation, weight equal to minus 44.533 plus 0.568 into height plus 0.945 into gender. This is all about multiple linear regression. So hope all of you understood about how to perform correlation regression, then regression line, scatter diagram, then simple linear regression, multiple linear regression in SPSS. All of you, I think all of you understood these things, and this is all about my check and answer, and then thank you.
Thank you, ma'am, for the informative session. Hope our participants have surely gained valuable information from this lecture. We'll again meet you on your next section. Thank you, ma'am.